Başla.
Hello all, this is Varnishing speaking. I am from WAT Motor. I'm responsible from the projects and the products in WAT Motor. First of all, I would like to thank you all for joining our webinar on structural strength analysis of electric motors. I believe you will find all answers to this special topic on mechanical forces, mechanical strength, and durability of electric motors. This is the live event session and it is recorded. So you can also watch this content on WAT Motor YouTube channel later on. Today we will be present this episode with my dear colleague, Mr. İbrahim Hakkı Durmuş. Actually, this webinar series will include 5 episodes. Those are on, as a first one, general characteristics of electric motors. The second one, and today's topic is structural strength analysis of electric motors. And the third one, which will be held in January next month, vibration and acoustics noise behaviors of electric motors. And the fourth one is thermal characteristics and behaviors of electric motors, which will be held on February next year, 2 months later. And as the last one, the international certifications and compliance of electric motors, which will be held on March. And this webinar will include 3 sections mainly. First of all, I'd like to start our webinar with short introductory presentation of WAT Motor. And after that, my colleague Ibrahim will present the technical parts. And finally, we will answer your questions that you share on Q&A section. Please share your questions by using Q&A section. So as a reminder, this is a live event session and it is recorded. You can also watch this content on WAT Motor YouTube channel later on. I'd like to start the first episode with WAT Motor presentation. Do you see my screen on presentation? Okay, thank you. WAT Motor history dates back to 1965 with the joint venture of Koç Group in Turkey and the General Electric of US. And what's known as Turkish Electric Industry, TEE, and what acquired some extra factories and merged with Arçelik Group, which is active on durable house goods. And in 2018, WAT became a standalone company, mainly focused on electric motor and its electronics. And we are mainly, our locations are in Turkey, and we are mainly active in European region and some other locations. Those are our locations in Turkey. Our factory and headquarters located in Çerkezköy, where about 1,100 people. Also in our R&D center on electric motors located in Çerkezköy. We have marketing and sales office in Istanbul, and also we have second R&D center on power electronics in Tuzla, in Istanbul area. Our facility has 40,000 square meter closed area, and we are about 87 kilometers away from Istanbul airport, and we are very near to the Greece border. As a short introductory, WAT is the export leader in Turkey on electric motors. We are mainly active in international sales and export markets. We have the largest electric motor and motor R&D center in Turkey. We are mainly strategic partner of most of the blue chip respectful global OEMs, mainly in European area. And we are also the Turkish electric manufacturer, motor manufacturer, in terms of international test certifications and compliance documentation. As I said, our company is active in export markets. Our main export market is through European region. We also export our products through the US market and also the Far East market. We are the only company which exports their products through China. This is provided by the China Energy Labeling compliance documentation. And also we want to increase our penetration into the emerging markets. We have some export awards in Turkey. We are ranked in 39th place in export of electric and electronics goods. We have two main businesses. Those are industrial motors, first of all. The second one is production issues for household electric motors. And we have several new business areas. Those are electromobility issues, motion control on renewable energy components. Also, our production and new investment are supported by Turkish government. We have incentive programs from the Ministry of Turkish Technology and Industry. Those incentives are announced by the President of Turkey. As I said, we have a very good R&D capability. So we have 90 people in R&D, nearly 70 of them engineers and designers. And also we have 20 people, colleagues, office technicians and laboratory technicians. We have all the background of software inventory and testing the laboratories, testing of electric motors in our laboratories. And I would like to mention several product lines which are released very currently. So this is our new IE3 efficiency level QN series. This series provided between 8 frame up to 132 frames. This is a very good design and combined with the latest production technology. We released this series this September, and the customers are receiving those products very newly. So as the new product release, we have smoke extraction motor series. Those are IE3 efficiency level. It could be IE2 efficiency level other than the European markets, non-regulated markets. So we provide 300 Celsius degrees resistant electric motor for smoke extraction in the fire circumstances. And also we are working on F400 series for higher temperature durability up to 400 Celsius degrees. For the new release, another example, the brake kit option. We are providing brake kit option for certain frame sizes. Those are 90 frame, 80 frame, 100 frame, 112 frame, 132 frames. This is a very convenient solution for the product. We have a small introductory video about this solution. You can also get this brake kit option, and you can convert your non-brake motors into the brake ones with the help of end shield. This end shield could be integrated, and also some extension part for the shaft. You will see it. Extension kit for the shaft. And also you can insert fan blades and the deep fan cover for this solution. You can also convert your non-brake motors into the brake mounts with your own. So we also start to produce 315 frame electric motors up to 200 kilowatts. Those motors could be provided both in IE3 efficiency level and IE4 efficiency level in 2 poles or 4 poles. Also, we can support you with this product. As a new project, we are now working on the electronically combined or electronically controlled electric motors. We will use these products in various applications. One main application of these products could be the ventilation business segment. Also, we have some outputs in mobility. We are mainly work on the light e-mobility solutions. We just introduced our electric traction unit electronic set for HMIs, onboard chargers, BLDC motor and BLDC inverter. Those could be used in electric mopeds, electric motorcycles, for personal use or for last mile delivery issues. Also, we have added some AC and DC chargers into our product portfolio. We provide those products for public charging or also with the private use. Those are some examples of our product line in EV chargers. And at the right-hand side, you can see our first installation in Yapı Kredi Bank in Bodrum branch. And we will also increase the numbers of those EV chargers, both in private use and both in public use. I already mentioned some numbers about our facility. We have very good production capability in terms of lamination presses, Stator and Rotor production capabilities, winding and varnishing premises, and we have some final assembly spots, and we also make our performance test on the line. We have a very good inventory for the production indeed. Actually, we have seamless quality assurance capabilities, which starts from incoming quality. We have a specialized incoming quality assurance lab, and also we have motor audit lab for the keeping production in a very smooth way. And we have several inventory for motor laboratory, also including environmental testing. Those are very brief information of what we have working on in WAT Motor side. Thank you for your attention. I would like to convey the speech through my dear colleague, Mr. Ibrahim, for the technical part. As I said, at the last part, we will answer your questions on this special topic in Q&A screens. Thank you very much and hope to see you at the final stage.
Okay, hello all. Can you hear me, Mr. Arturo? Okay, thank you. Thank you for the introduction. I will share my screen. Okay. Hello again. I would like to present our presentation webinar where we will give you information about how we do structural strength analysis. I am Ibrahim Hakkı Durmuş, working as a research and development specialist at WAT Motor Company. I provide various analyses and evaluations with analytical calculations and simulation tools, especially in static structural analysis, to the R&D teams that intensively produce structural design outputs. First, let's take a quick look at the presentation content. At first, we will talk about the concept of structural strength and its basic factors. Then we will briefly touch on the analysis cycle. Next, we will focus on the elements needed to create this cycle. For example, after quickly looking at the motor mounting types, we will examine the internal and external loads acting on the electrical motor and the components that transmit these loads to each other. We will look at the material information which are so critical to the analysis. And finally, we will come to the end of the presentation with the creation of the simulation model and the interpretation of the results. Before the structural strength analysis, I would like to briefly talk about the importance of the structural strength and what it is. Structural strength is an important property for any structure designed for any purpose. Although the structural strength in some critical designs are strengthened over time and experience, points that are overlooked, especially in designs, may cause a structural failure in short or long term. Structural failure of machinery equipment may cause damage to peripheral equipment and systems, disruptions in mass production, and therefore loss of profit and production. And most importantly, it can pose a very serious risk to human health as well. Let's start by examining structural strength conceptually. Any product we produce, for example, a rod attached to a wall, like here, must have a structural strength against the loads to be applied on it after the design and the production processes. To make sure of this, we must review the factors that affect structural strength. For example, geometry includes important parameters that affect the rigidity of the structure directly. As you can see, the amount of applied load directly affects the stress formed up to a limit. Boundary conditions determine how the applied load will affect the structure. As a result, it changes how stress distributes over the structure. And finally, material properties determine to withstand these stresses that occur under all of these conditions or to structure to fail. For example, yield strength value. Let's take a brief look at the paths we follow in conducting structural analysis. Let's imagine that the important factors we've just mentioned come together to form a static structure like this one. In order to create this setup, after the necessary research is done and information such as CAD data and material information is collected, a copy of a real structure is tried to be created inside the computer environment, which called a simulation model. After applying the conditions to this virtual copy, the computer gives us the stress distribution map, just like this one. Stresses are important for our study of structural strength because structural failure theories say that structural failure occur as certain stress limit values are exceeded. For example, the von Mises failure criteria. To find out these limit values, we look at the properties of materials, such as yield strength value. or such as fatigue strength limits for cyclic loads. To be able to compare these criteria in a simulation environment, first we need to get to know the structure a little more. For this reason, let's take a brief look at the mounting types of the motors. We can divide motors into two categories, main categories, as those that are mounted from the foot and those mounted from the flange. Right here. Foot-mounted motors, like those ones, are connected to the outside world by feet attached to around the body. It can be connected in various orientations. And orientation changes the direction of gravity, especially for large frame motors. It becomes more and more important. Flange-mounted motors are connected to outside world through the drive and covers that also house the output shaft. And again, as you can see, that they are connected in various orientations as well. Now let's look at the loads that can be applied to the electrical motor from the outside. Motors can be exposed to various load cases in various applications, such as pumps and compressors. These loads can be applied to the motor in radial and axial directions from the shaft output. However, the axial load needs to remain low due to bearing limit values for the standard applications. In addition to external loads, electric motor can also be exposed to a breakdown torque caused by electromagnetic forces created by itself in sudden situations. In addition, according to the assembly types of the components, preloads may be present between the components. For example, frame stator interference pressure and bolt pretensions. These ones. Electrical motors consist of many parts that transfer loads to each other. Among these parts, we can say the shaft covers, body bearings, and feet carry the greatest loads. The load applied from the shaft end is first transmitted to covers by means of bearings. Right here and on the non-drive side. It is transferred to the frame with bolt connections over the cover, and from the frame to the feet and feet to the ground with bolt connections as well. The breakdown torque is transferred from stator frame contact surface to the frame body, and that from the frame to the feet and finally to the ground in a similar manner. The stator body can interference pressure acts as in the radial direction. The cylindrical interference pressure, fitting pressure surface. It can also be considered as an other internal stress. If we look at the material properties, we see different yield strength limits in different materials. These values may vary in different contexts. But for example, if you look at the stress strain curve for steel in the this part, curve of, we can see that the linear behavior starts to change after a point. This point where elastic behavior ends and permanent deformation begins. For static structure, we would like not to exceed this point in stress value. As a result, no permanent damage is observed on the structure after the load is removed. Fatigue is the value at which stress values that cannot reach that static limit begin to damage the structure repeatedly, which may lead to structural failure as well. Theoretically, for infinite fatigue life, it is necessary to stay below the area where the ascent curve flattens, like these ones. And there is another example for ascent curve. Also, ascent curve for gray cast iron is presented. Okay, let's make a little summary. We looked at so far topics as mounting positions of the motor, external loads acting on the motor, and internal connections and loads of the motor, material properties which we are needed to know. Now we can gather them all and take a look at their equivalence in the simulation environment. In fact, our simulation model consists of factors that are important for structural strength, just like we mentioned before. It is necessary to define the material by making use of libraries or research that contain material properties, such as elasticity modulus and density of the material. We need CAD data as well to get the geometry of the components, their position and orientation in assembly. And we define the contact areas that are touching in real life within this data manually or with some automated tools and with some surveillance. Similarly, to simplify the model, we define remote effects of missing components with joints, like bearing effect from shaft to the cover, just like here. For example, while bolts are not available as a 3D CAD data in this assembly, we define them as a beam elements. As a result of all these stages, we have obtained a model whose material is defined, connections and boundary conditions are determined until now. Now we need to apply the internal and external loads acting on the motor to this to our model. Let's start with preloads first. We need to apply the clamping forces calculated by analytical means on the bolts we defined earlier. We also apply the pressure caused by the body and stator interference to the frame surface inside here. We also include the weights of the components that are not included for simplifying the model, such as stator, to this area. If we look at the external loads, we apply breakdown torque to the stator contact surface area and the radial load to the shaft end from here. While we reference catalog values for shaft and radial forces, we use information from electrical design team for breakdown torque values for new designs. Okay. However, it is necessary not to consider the radial load acting on the shaft, not in a single direction. The electrical motor can be subject to radial loads in different directions in different system designs. For this reason, we can obtain a quasi-static state in the analysis defined by defining the radial loads by separating its vectoral components and changing these component values in a sinusoidal construct, just like here. Structural strength analysis against loads in different directions can be examined according to these defined steps here. Our boundary conditions also usually defined in regions where our models connect with the outside world. It is important to use linear boundary conditions whenever possible to obtain analysis results earlier and optimizing the model. If we examine the stages in the simulation model, we will see the editing the CAD model to fit our results and defining the materials for every component and linking the components together with tools and then defining loads and finally defining boundary conditions. Next step is to extract the mesh structure by discretization of the geometry. Various methods have been developed for this operation, but mesh structure affects simulation time and the result accuracy. Thus, we need to combine these operations to achieve optimal mesh structure. And later, result of all the information given to the computer, the simulation program generates the strain distribution map by solving the geometry segmented with mesh. Based on the strain map, the stress and displacement distribution also be created. From all the assumptions we made on the prior steps, the numerical method induced errors and the errors in the model we built. A resulting error occurs between the actual stress and the stress simulation output. Up to a point, some amount of this error is natural. To minimize this error, measurements are recorded with the strain gauge sensors and validations are made. And errors in model or assumptions are reduced as far as possible. Okay. According to the von Mises criteria, this equivalent stress value is taken account for ductile materials, and these values are compared with the distribution on the structure. For example, aluminum alloys. Another evaluate for the results, just like brittle materials like cast iron, the maximum principal stress value is taken account for similar criteria. Stress distribution you can see on a cover, but when evaluating these results, rather than taking a singular maximum point value in the geometry of the stress distributions, the values that has wider spread on the structure are examined, and these values are compared for the strength limit values. And we can make some deductions. We take those results and compare with them to materials yield strength value for static evaluation or cyclic evaluations. We consider fatigue strength, but to achieve infinite fatigue life, it is better to stay under this fatigue strength with a factor of safety value. Now on this page, we can see distributions of the shaft, but it is also advised to conduct another simulation with more finer mesh and with another type of strength. Okay, as far we reviewed some results like frame, feet, and cover. And other important components to review. Also, there are some other components as well. Other components such as bearings, bolts, and shafts make up the structure should also be evaluated with analytical tools or numerical tools such as finite elements analysis. I may wrap up the presentation. Thank you for attending.
Thank you very much, Ibrahim. I hope you enjoyed the presentation and the technical content. If you have any questions or any additional comments, you can share those on the Q&A part of the screen. We will be answering your questions in the third period, this period. Yeah, we have 2 published questions at the moment. We can continue with that. I'd like to read Mr. Abdelrahman's questions. Ibrahim, maybe you can answer the first question. This is about the durability of the electric motors in different situations. Maybe you can answer those.
Okay. I'm going to read the question. Can change the base of motor to be more durable and forced against the force of load than usually used to now, because I saw 2 bolts only carry motor body and connect to the base. Actually, for this reason, we are trying to select the best bolt measurements for these appliances, because we have to calculate these results analytically. We make calculations and we make assumptions, so we can select the best bolts. But also you can use on some motors there are another hole to fit, and I guess for maximum effectiveness it can be used, but I don't think it is regarded for normal use case.
Thank you very much, Ibrahim. Also, you can share your questions, as I said, Q&A screen, Q&A part of the presentation site. This second question is also about the technical question on driving and fixed or floating bearing installation. Ibrahim, maybe you can also continue with answering this question, and also we can change the screen to Ibrahim, maybe, Arzu.
Okay. And we were asked that what's the difference between fixed drive side bearing and the floating? It affects to the use case. We can change the arrangement, so we can gain maximum bearing lifetime. If we fix the drive end side, axial loads will be carried through the drive end side bearing, in addition to the radial loads. So its total load will be much higher than the usual, since the axial loads are much more effective against the standard ball bearings. So for any use case, we change the arrangement of this system.
Thank you very much, Ibrahim. I hope we answered this question. It depends on the forces, and it depends on the application mainly. it could be analyzed, yeah, and according to the bearing life, it could be analyzed very carefully because it is very dependent on the durability and total lifetime of the electric motor. And this is a very good question. Thank you very much.
Also, he asked that is it for fixed boundary conditions on the drive end side of minimizing the displacement on the drive end side motor, which may impact the performance of the system. I don't think so. It's the main advantage of fixing either side is to balance the lifetime of the bearings, because when you fix, you only fix on the axial displacement. So maybe it affects the axial displacement, but it wouldn't affect the radial displacement. Thank you for question.
We have another question. This is also about the bearing. Ibrahim, maybe you can also read and answer these questions. Alper Bey asked this question.
He asks that what do you think about define just bearing load by using momentum equation instead of rotor weight on the shaft? Is there any difference? Thank you for the question. It changes. It depends on the frame size, I guess, because when the frame size getting bigger and bigger, the rotor weight is increasing in much faster period. So we need to take into account of the rotor weight as well for a bigger weight, bigger frames motors. But for a small motor, I think in some cases we can exclude that parameter from the calculation.
Okay, thank you for the question. We have 3 questions up to now. If you have any questions, we can wait for a while to write it down in Q&A screen. Thank you very much for your attention and for the joining of this webinar on mechanical characteristics of electric motors. If you have any questions, please share those in Q&A screen. We will wait for a while, and after that, we will conclude this session. We would like to receive your questions, and we are, as I said, waiting for a while. I think those are the all 3 questions. Thank you very much for joining us and for the time you spent in this webinar session. As I said at the beginning, we will continue in these webinar episodes and webinar sessions in the next month. The 3rd one will be on the vibration and acoustics behavior of electric motors. This is also a very special and very expert. The topic required deep expertise. We will share very interesting information and technical issues with vibration and acoustics behavior, which is a comfort parameter, quality parameter of electric motors. This webinar will be held in January, and after that, our 4th episode will be on thermal characteristics and behavior of electric motors. It will be held in February, and the last one is the 5th webinar episode, the international certification and compliance of electric motors will be held in March. We will also announce the time schedule of this webinar series on our Instagram and LinkedIn platform. As I said, thank you very much for joining us in this webinar session. Before closing, we have 2 additional questions. We will answer those questions and close this session. Ibrahim, maybe you can continue.
Okay. Our faces of motor have cast shield around the bearings to protect aluminum faces from damage or scratches. Yes, we use steel bushings for this purpose on our motors. Thank you. What is impact of the critical speed of the rotor on performance of the motor? It may have electrical effects, but on the mechanical side, I can say that critical speed may heaten up the bearings to a degree that which we do not want because of the fatty the bearing life. So it is better to stay the lower speeds for the bearings specification for specific motors. I guess I can say those for mechanical aspect. And also there is a viewer said it was very useful. Thank you. Thank you as well for attending.
Thank you very much, and we hope to see you in our next webinar episode, which will be held in next month in January. Thank you very much for joining us today. See you and have a fruitful week. Bye bye.
Thank you. See you.